In this video, we're going to talk about amplitude, period, and harmonic. I'm Dr. AVITECH, and on my channel, we deal with mathematics and engineering. So remember to hit the subscribe button, like this video, and share it across to your classmates. And most importantly, always turn on post notifications so that anytime I release a video, you'll be the first to receive it. So let us talk about amplitude. Now, earlier on in should I say earlier classes or earlier grades or in secondary school or in colleges, we've done amplitudes before. We've been told that, oh, amplitude is the maximum displacement of a particular graph or function. I love to call amplitude the height because amplitude determines how high a function goes. That is what it determines. Now, if y is equal a sine x, y is equal a sine nx, for example, then the number in front of this very sign tells us the height of the function, how high it's going to go. So that is what it tells us. So currently, if you compare this to this, I believe you can tell what the amplitude is going to be. So the amplitude tells us what the height is. Then how about period? So A is equal amplitude. So A is equal amplitude. Then what is the period? Now, period is actually time. Remember that when you're dealing with the word period, it means you can use the word periodic. So when something is periodic, it means it is always repeating itself. It is always repeating itself. So many things around this world repeat itself, not just maths. So many things repeat themselves. The day repeats itself after every 24 hours. The number of weeks we have come again when we have Sundays. Females, they experience periods. So it is actually not just maths. There are periods everywhere. So what is period in maths with respect to maths? So period is actually the time it takes to complete one revolution. The time it takes to complete one revolution. That is what period is. How long does it take to complete a revolution? Now remember that revolution means you're going around something. So revolution is 360 degrees. Now, but more conveniently, we prefer to use 2 pi radians. So we prefer to use radians instead of degrees. That's still the same thing. So there's a conversion going on. So 360 degrees is same as 2 pi radian. So we just prefer to do it like that. Now, how do we then find the period of sinusoidal functions, sine and cosine? How do we find the period? So the period is 2 pi over n. That's how we find the period. That's how we find the period. 2 pi divided by what? N. So if you compare this, you will see that, oh, there's an n right here. So the number with x, the coefficient of x, is what n is going to be. That is what it's going to be. So let us just find this in some of these functions. So for the first one, the amplitude is 3. Because that's the number in front. Remember that amplitude is just the number in front. Then what's the period? The period is 2 pi over n. But what is n? N in this case is what? 5. So that will just be our period. That's our period. Number 2. The amplitude will be 2 because 2 is the number in front of cosine. So it's still the same thing. Either it's sine or cosine is still the same. Then our period will become 2 pi over n. But our n in this case is what? 3. We're comparing this equation to this equation. So there's a sine nx. There can also be a cos nx. So n is that number in front of x, then a is the number in front of cosine. Number 3, the amplitude is 1. Yeah, should I say visible imaginary 1? So that's the amplitude. Then the period is 2 pi divided by. Now, if you take a look at this, it's looking as if there's no, the n here is actually 1 over 3. Because the equation of x is 1 over 3. There's an invisible one at the numerator. So if you have a fraction, there must always be a numerator. So that's 1 over 3. So this is 1 over 3. Now, do you know that you can actually say that the 3 will go at the top? How fractions work? This 3 goes to the top. So this is 2 pi times 3 over 1. So this will then become 6 pi. And that's the period. That's the period. Number 4, the amplitude. This is 6, right? So the amplitude is 6. Then the period is 2 pi over 2 over 3, because n in this case is 2 over 3. Now there's a better way to do this. Let me do it like this for you. Now this is 2 pi. This division sign, you can write it like this, divided by, then you put 2 over 3. Now this is 2 pi. When you change the division to times, this would then become 3 over 2. Because you flip the fraction whenever you change division to times. So 2 we cancel out 2. This will then become 3 pi. You can see that, right? So that's how you get the period for that very one. Then number 5. Let me just do number 5 here. So number 5, the amplitude is 7. Then the value of n here is what? 1. Because this is nx. Remember, nx. So n is 1. So you have 1x. So n is 1. That means our period is 2 pi over 1, which is then just 2 pi. So that is how you find your amplitude and your period. Let's talk about harmonics. In electricity, they kind of call harmonic distortions. So we have what we call distortions, but I don't want to talk about that. So let's talk about harmonics. I think I should just write something around here. So harmonic is an integer multiple. So it's an integer multiple of the fundamental frequency. Fundamental frequency of a periodic function. So if you multiply your fundamental frequency, you're going to get your harmonic. I'm going to explain what this is. So let me draw the graph of sine. Let me just draw the graph of sine. I hope I can draw it very well. So we have something like this. Okay. So this is +1, this is -1. Yeah, something like this. Now, as you can see, this is from 0 to 2 pi. Or you could say 0 to 360. So that's one revolution. Now, as you can see, this is just one cycle, right? This is just one cycle. Please take note that frequency and period are closely related. They're just the reciprocals of each other. So this thing you see right here, this is just one period, because you are just having this thing going. What am I even saying? Sorry, this is just one cycle. Now, this very cycle you see here, is the fundamental frequency. So the fundamental frequency is the first harmonic, because you have just one cycle here. Sometimes I kind of like calling this harmonic. I kind of like calling harmonic the number of cycles. Should I call it cycles? Okay, yeah, number of cycles or circles. Let me just call it circle. Number of cycles per 2 pi or per 360 or for one revolution. So since I have just one cycle here, it's just the first harmonic, which is the fundamental frequency. Now, the next one, let me say that I have another graph. Something like this. Now, what do you notice here? We're having two circles here because from this point to this point is 1. If you notice, this part will perfectly be covered by this part. If you rotate this, this part will be perfectly covered by this, while this part will be covered by this, even though it's not perfect, but I'm trying to explain something. So this and this, they would all match up to become two cycles. Now, what do you notice? This is actually an integer multiples, because this very function I've just drawn, the first one is just y equal to sine x. This next one is, let me just say, y equal sine 2x. I don't really want to talk about the amplitude yet, but y equal to sine 2x. So when I say 2x, this means I'm talking about this very function. Then what if I have 3x or 4x? You then notice that we're going to be having something like this. So there will be more number of circles with respect to how many times I increase my n. Remember that we had y equal a sine nx. So the n here tells me the nth harmonic. So how many circles, how many cycles? Say how many circle, please? I think it should be cycle actually. Sorry. Yeah, it should be cycle. So how many cycles do I have in just one period? Because sine s is periodic with 2 pi. So how many circles do I have within just that period? That is what harmonic is. So right now, if I have just one cycle, that's the fundamental cycle. That's the fundamental frequency. And that's also the first harmonic. So the first harmonic is the fundamental frequency. It's the same. Then when it's 2x, that will become the second harmonic. And when it's 3x, that will be the third harmonic. So if you have something like y equal 5 sine 6x, for example, my amplitude here is 5. My period will be 2 pi all over n, but n in this case is 6. So this will become 2 pi. When you cancel out, when you divide by 2, that will be pi over 3. And then, what will become the harmonic? This will become the sixth harmonic. Because this is 6 times the fundamental frequency. The fundamental one has just one cycle. Just one cycle. Then, you are then multiplying by 6. So, if you should sketch this very sine 6s, you'll be having 6 cycles before you get to 2 pi. 6 complete cycles before you get to 2 pi. So that is just what harmonic is. And with this, I'm going to end this video and I'm going to see you in the next one. Thanks for watching.